Good afternoon, everyone. My name is Donna Ennis, and it's a pleasure to have you here today to hear about machine guarding, our webinar with our Georgia Tech Safety and Health Environmental Services Group. Again, my name is Donna Ennis, and we'll talk a little bit about who we are before we get into the presentation. Before we start, I'd like to thank our sponsors, Comcast, EPCO, and Train Technologies, for their continued financial and, if you will, moral support of the programming here at the Atlanta Minority Business Development Agency, or MBDA Centers. The MBDA Centers at Georgia Tech are, our main mission is to help grow and strengthen minority business enterprises. We like to provide all kinds of training, education, and technical assistance to help them experience significant growth, with the result being to create jobs, retain jobs, and therefore have a positive impact on our community. We are part of a national network of centers, 40-plus centers and projects that are partially funded by the Minority Business Development Agency out of the Department of Commerce. At Georgia Tech, we have two centers. We have an Atlanta MBDA Business Center, which we've had since 2004. And in 2016, we established a specialty center, which is the Atlanta MBDA Advanced Manufacturing Center. MBDA currently has 4 manufacturing centers across the country, one in San Antonio, Detroit, Baltimore, and of course here at Georgia Tech in Atlanta. We also have 4 export centers that help our companies export their products and goods and services to all parts of the world. We are focused on Africa, Latin America, and Asia, and the Caribbean. And then we have a federal procurement center in Washington, D.C. that helps our companies secure federal contracting. So we're all working together across the country to bring education, training, technical assistance, access to capital, and opportunities to minority businesses. Here's our team. I just want to thank everyone on the team for helping to work with us to grow and strengthen minority businesses. From Brandy Nagel, who is the program manager for our Advanced Manufacturing Center, Lauren Roberts on the line, our program specialist, and Aisha Jones, who is our special events planner. But for this particular webinar, I do want to call attention to Anthony Jackson, who is our manufacturing advisor, as well as Dr. Billy D. Brown, who is our manufacturing advisor for the Georgia Tech Manufacturing Institute. He works there. And for those of you who are on the line who are manufacturers, we have a broad scope of services and assistance to help you grow your manufacturing operation, including our Georgia Manufacturing Extension Partnership Program, as well as our Trade Adjustment Assistance Center. So I say that to say Georgia Tech has been in the manufacturing space for quite some time, and we're here to help you grow. This program is being brought to you by some special funding from the CARES Act. The Minority Business Development Agency receives funding from the CARES Act to bring specific assistance as a result of the pandemic. So here we are with the training and we have technical assistance. We also help you secure Paycheck Protection funding, PPP funding, as well as to ensure that you're compliant with your PPP funding so that your funding will be forgiven. We've seen a proliferation of grants as a result of the pandemic, so we try to keep our fingers on the pulse of as many funding opportunities, particularly around relief from the pandemic as we can. And then we consistently do pulse checks and pivot strategies with our companies. So feel free to reach out to us if you have any needs and assistance around any of these areas. So without further ado, let's get on with our machine guarding overview. It is jam-packed for the next hour, 15 minutes with all kinds of technical information. And I'm going to turn it over first we have Rachel Snyder with the Self-Healthy and Environmental Services Group, known as SHES. And she'll kick us off. Rachel, you're up.
All right, thank you so much, Donna. Schneider, am a safety consultant with our OSHA consultation program that's run here at Georgia Tech. And so we are going to talk about machine guarding and OSHA's machine guarding standards. So as a safety consultant, I go to a lot of manufacturing facilities, and we oftentimes see employees being exposed to machine hazards. And OSHA has several machine guarding standards, but again, we still oftentimes see machinery either not being guarded properly or not being guarded at all. So we just wanted to begin this webinar by talking about why machines may not be guarded. And these are some responses that I have heard in the past when I'm out in the field, and perhaps you've heard them as well. So first one, no one would stick their arm, hand, finger, head, etc. in there. Sometimes I will address a particular machine hazard at a company, and they might respond by saying, well, if you had common sense, you would know not to stick your hand in that machine, or not put a body part in the point of operation. But the one thing I try to remind my companies is that what is common sense to one person may not be common sense to another, right? So maybe you have a particular employee and they didn't get a lot of sleep the night before, or maybe they have a stroke on the job, or they're thinking about something going on in their personal life, and so they're distracted and they make a mistake. So it's not adequate to just rely on your employees to exercise common sense. You have to engineer out those machine hazards so that in the event that employee does make a mistake, they aren't exposed to any hazards. And then along those lines, no one is supposed to be back there, in there, around it while it's running. What if you have a new employee and they are, they're new and maybe they didn't receive training on where they can or cannot go. And so now they're in an area where they're not supposed to be, or maybe an employee drops a tool and they have to go behind a machine. And so you want to restrict those areas so that employees have no access to the hazards. You don't want to just rely on them to not go where they're not supposed to go. And then the machine came that way. It never had a guard. We hear this one a lot. However, from an OSHA standpoint, it is the employer's responsibility to ensure that the machines on site are properly guarded. It is not the responsibility of the manufacturer of the machine to ensure that the machine is guarded. Rather, it's the responsibility of the employer to ensure that their employees are protected from machine hazards. And then I've been doing it this way for 20 years, without any problems. I hear this one a lot too. I might tell an operator that a machine needs to be guarded, and he might respond by saying, well, actually I still have all my fingers, so it should be fine, right? But whether or not you still have your fingers, the machines still need to be guarded. And then, let's see, the guard is in the way, right? So during this webinar, we are going to discuss different ways that you can guard your machines. If a particular guard is in the way, or if it's introduced a new hazard in itself, then you will want to reevaluate your machine and see if there are alternative ways to protecting your employees from the machine hazards. And then the OSHA inspector didn't say anything about it. So just because the OSHA inspector didn't say anything about it does not mean that you are now exempt from guarding your machinery. There are many reasons why an OSHA inspector may not address a particular machine. Maybe you had an industrial hygienist that was your inspector and they were focused on health hazards, or maybe they were just focused on a particular area of your plant. And then we'll put it back on if OSHA comes. So, when it comes to machine guarding, the point is not just to please the OSHA inspector. The reason why OSHA exists and the reason why the machine guarding standard exists is so that employees are protected from machine hazards, so that they're not killed or seriously injured on the job. So one of the main concerns with machinery and machines not being guarded properly are amputations. And amputations can occur on many different types of equipment if they are not properly guarded. So you have your power presses, you have your shears, your saws. I know I have friends and family members that have lost fingers while operating saws. You have your press brakes. These are used to bend metal. And when that press is coming down, if your fingers are in that point of operation, the press is going to win. Your fingers will be amputated. You have slicers, conveyors even, so employees could get caught into the equipment or caught around it. Printing presses, roll forming or bending machines. So again, employees could get caught into that equipment. And then even drill presses and milling machines. I'm sure many of you all have drill presses or milling machines in your facilities. They're very common pieces of equipment, and amputations can even occur on these. So hazards can occur in several places on a piece of equipment. They can occur at the point of operation. So say you have a shear. Well, the point of operation is going to be that shear point, so where the cutting is being done. Or if you have a press, the area where the press comes down, that is going to be your point of operation. If your hands are in that area when the machine is operating, it's very likely that you could lose some fingers or lose a hand. Hazards, machine hazards can also be present on your mechanical power transmission equipment. So like your belts and pulleys, chains and sprockets, rotating shafts, flywheels, basically any equipment where maybe a piece of clothing or a limb or hair could get caught into or around it. Those are all going to be, hazards. And then any other moving parts. So any rotating parts, sometimes, vibrating or shaking parts may also pose a hazard. So when you guard machines, you want to make sure that they prevent hazards, right? So employees should not be able to access those machine hazards. And then the guards also need to be secured to the equipment so that employees can't just lift them off. I have been to plenty of facilities where they have a guard that's placed tenderly, over the equipment, and then an employee needs to inspect something and they lift it up easily, and now they're exposed to those hazards. That's not okay. So your guards have to be secured to your equipment. If you have equipment or machinery that is overhead or over a work area, then the guards would also need to protect from any falling objects. Your guards also can't create any new hazards. So sometimes companies will maybe like a barrier guard to a piece of equipment and it goes up and down maybe with the equipment, but then now you have a pinch point hazard. So you need to make sure that you're not introducing any new hazards. Your guards also can't interfere with the work that's being done, and you still need to be able to maintain your equipment. So maybe, if you have chains and sprockets, you may need to add spaces for like oil feed tubes on your guard. So the overarching general principle for machine guarding is that you must not be able to reach under, over, through, or around the guards and access the hazards. So whenever you're adding guards to a machine, you really need to consider, can I access the machine hazard by reaching under, over, through, or around the guards? And it's very important that you also make your employees aware of this requirement too. All right, so here are some examples of, different machine hazards that may be present. So we've got, well, normally these are animated, but it doesn't look like they're animated right now. But we've got chains and sprockets, meshing gears, a punch press, belts and pulleys, even fans, a bench grinder. The bench grinder is actually well guarded here. We have a rotating auger, a shear, right? So all of these pieces of equipment would need to be guarded. So there are 3 different methods of machine safeguarding or machine guarding. And we'll get into each of these methods in more detail, but you can have physical guards like your barrier guards. You can have devices, so like light curtains or laser systems or pressure sensitive mats, or you could also guard by location or distance. All right, so physical guards may be fixed guards. So these guards are, secure to a machine. Say maybe you have like a chain drive or chains and sprockets, then you would close them with a fixed guards or a barrier guard. Physical guards may also be interlocked so that if you open them, during the operation of the machine will shut off. Some machines are going to be equipped with adjustable guards where the operator will need to adjust the guard to accommodate for the size of the stock that's being worked on. And then other guards include self-adjusting guards. So that's where the guard will actually adjust based upon the width of the stock that's being fed into the equipment. So an example of a self-adjusting guard is a hood guard on a table saw. So as you're feeding that wood into the saw, the guard is lifting up and it's allowing you to feed the stock in. And then when we talk about presence sensing or safeguarding devices, we're talking about presence sensing devices. So your light curtains or your laser systems, where if you break the plane, then the machine will shut off. We really don't see pullbacks and restraints anymore as a means of guarding, but they were once used to guard machines like press brakes to prevent operators from accessing the point of operation. We do see safety controls and safety trips, such as like trip wires, pressure sensitive mats, two-hand controls. And then we also see gates, which are used to prevent the operator from being exposed to the point of operation once the machine begins to operate. All right, so this is a diagram that demonstrates how large the openings in a guard can be given the distance the guard is from the point of operation. And one device that we as consultants is what we call the gotcha stick. And so it's basically used to measure exactly what this diagram is showing. So on the x-axis, you have the distance between the guard and the point of operation. And then on the y-axis, you have the maximum opening allowed in the guard. And as you move further away from the point of operation, the size of the opening that's allowed in the guard increases. So these gotcha sticks are really useful, especially if you aren't sure if a guard is sufficient. You can use the device against the guard to see if the openings in the guard are too large or if they're sufficient. And I know you can get these online. Rockford Systems sells them. I've seen them on Amazon before, but they're very handy. All right, so these are examples of fixed guards. So fixed guards are typically constructed of metal, so sheet metal, expanded metal, or perforated metal, and they completely enclose the danger area. And then in order for employees to remove the guards, they must use a tool, right? So they shouldn't just be able to lift the guards off. Every time a guard is removed, you would need to make sure that employees are performing lockout tagout beforehand. And just as a general rule, power transmission apparatus, so like your belts and pulleys, chains and sprockets, that equipment is best protected by fixed guards because they just completely enclose the equipment. Whereas these guards may not be favorable for hazards at the point of operation where moving parts are performing work on the stock. So if a fixed guard isn't feasible or practical for guarding the point of operation, there are still several different types of safeguarding that are possible. So with your interlocked guards are going to look like a barrier guard, but you can open up the guard, and when that guard opens up, then the machine stops operating. So this photo is of a revolving drum with an interlocked guard that's in the opened position. And so since the guard is open, the drum should not be able to rotate. And then once the guard is put back into place, the machine can start up again. All right, so here's an example of an adjustable guard. So adjustable guards provide a barrier, but again, they can be adjusted to accommodate for various sizes in stock. because they do require adjusting, they are subject to human error, because now that responsibility, falls on employees to adjust the guards based upon the size of the stock that's being worked on. We typically see adjustable guards being used on bandsaws, but with bandsaws, you want to make sure that the non-working portion of the blade is guarded. And if you have vertical bandsaws, then you want to check underneath your tables and make sure that the blade underneath the table is also guarded. So when I say the non-working portion of the blade, that means, the area where the work is not being done. So only the part of the saw where the cutting is being done can be left exposed. Everything else would need to be guarded. So with self-adjusting guards, the guards themselves will move and adjust according to the size of the stock that's being worked on. And these guards are frequently seen on like woodworking equipment, so table saws, chop saws, radial saws too. And self-adjusting guards do avoid that potential for human error that's associated with just your adjustable guards. But the main problem that we see with these guards is that employees will take them off. So if you have self-adjusting guards, on your equipment, just make sure that they do stay in place. If they're in place, then they'll do their job, but you just need to make sure that employees are not removing them. All right, so now we will move into just some different types of safeguarding devices. So presence sensing devices include light curtains, laser systems, also bump guards. And with light curtains and laser systems, you have to set, with light curtains, you have to set up, the rods, and then and then they create a plane. And then whenever the machine operator crosses the plane, the machine will stop operating. And so these are very effective ways to guard machines such as press brakes and power presses, but you still need to make sure that they are set up properly and that they're functioning properly. I have seen plenty of power presses where the front and the sides of the press are equipped with light curtains, but then in the back of the press is left completely exposed. So you do need to make sure that every area where employees may access the hazard is accounted for. And then employees should also test the light curtains or laser systems to ensure that they are functioning properly. All right, so here is an example of a light curtain. And so you have the rods on both sides, right? And then those pink bars represent the invisible plane. And so if that employee crosses that plane, that machine should shut off. So this is a good example of a well-guarded machine because not only do you have the light curtains at the front, but you also have barrier guards on the sides of the machine as well. There we go. I think I accidentally zoomed in. There we go. All right. So these are pullbacks and restraints. They were once used as a means of guarding for presses, but they really are not that common these days, primarily because of the ergonomic hazards that they present. So the photo on the left is of a man who is hooked up to a pullback device. And basically how it works is the device will pull his hands away from the point of operation when the ram comes down. And then on the right is an example of a restraint device where the restraints are adjusted so that the employee's hands are kept out of the point of operation. Now, we do see two-hand controls quite often. So with two-hand controls, the operator needs to apply pressure to both controls in order for the machine to operate. So with two-hand controls, one thing you do need to keep in mind is whether other employees in the work area are also protected. So if the operator of the machine is the only one in the work area and it's not possible for other employees to be exposed to the machine hazards, then two-hand controls may be a sufficient means of guarding. But if you have other employees in the area who may also be exposed to those machine hazards, then your two-hand controls do need to be supplemented, with another means of guarding to protect your other employees. You also need to ensure that employees are not bypassing these guards. They can get really creative, when it comes to bypassing two-hand controls. Maybe, I've heard of employees setting down their forearm to press down the controls while using their hand to like make adjustments to the equipment or to the stock. Or maybe they'll have one employee push down the controls, but then another employee is exposed to those machine hazards. So you need to make sure that, again, all potential access points for both the operator and employees in the area are guarded, and that employees have no way of bypassing these controls. So safety tripwires are devices that are located around the perimeter of a danger area or near the danger area. And when the tripwire is pulled, the equipment will stop. With tripwires, the operator must be able to reach the cable to stop the machine. So I've seen tripwires that are, way up here. And so it would be very difficult for an operator to reach the tripwire, especially if in the event of an emergency. So they do need to be easily accessible. And the machine also needs to be able to stop fast enough for this to be considered a sufficient means of guarding. Typically, tripwire cables are not optimal when it comes to machine guarding, but in some cases they are the only feasible option. So in this photo, we have a set of rollers that are equipped with a tripwire. And so we'll see tripwires being used primarily as a secondary means of guarding, such as on conveyor belts. And again, with these, just like with your light curtains, you do want to make sure that they're working properly and they're set up properly. All right, so these are presence sensing mats. So when employees step on these mats, the equipment would shut off or stop. So just like with the other presence sensing devices, these do need to be set up properly and they need to be maintained. So you want to make sure, again, that all potential points of exposure on the machine are accounted for. So maybe that means installing pressure sensitive mats around the perimeter of a machine, or maybe incorporating different means of guarding around the machine, such as barrier guards or light curtains. And then gates are another type of machine guards. So they will open so that material can be fed into the machine. And then the machine cycle will not start until the gate is fully closed. With gates, again, you want to make sure the entire perimeter of the equipment is guarded, but gates are a good option because they may provide protection not only to the operator, but to other employees in the area as well. So in these photos, you have a press with a gate guard, and the picture on the left shows the gate open and the point of operation is accessible. And then the picture on the right shows the press with the gate closed, and now the point of operation is not accessible. And then when you safeguard by location or distance, the machine or its dangerous moving parts must be located so that they are not accessible or do not present a hazard to workers during normal operations. So in this photo, you can see that the operator controls are located at a safe distance from the machine. Another approach is to locate the machine so that a plant design feature like a wall protects the worker and other personnel. And then also you can use enclosure walls or fences too to restrict access to machines. I've seen that a lot. And then if you have, if you're able to, you can also put your dangerous equipment or parts high enough so that they're not within, normal reach of any worker. Now we do see protective shields quite often, especially on lathes and drill presses. So lathes and drill presses and milling machines do need to be equipped with protective shields. We call these chuck guards. And so they don't give complete protection, or they don't provide complete protection from the machine hazards, but they do provide the operator just with an extra margin of safety because they protect the operator from flying particles, splashing cutting oils or coolants. And we wanted to show you two different types of chuck guards. So on the left, we have a telescoping chuck guard. And we actually don't recommend that companies use these because what we've come across is that they're kind of a nuisance and they get in the way of the work that needs to be done. And so employees are likely to just remove them. But we do recommend the type on the right. And so this is like a plexiglass shield, and you oftentimes they'll have like a magnetic base, and you could just put it over the point of operation. And these are a lot easier to use. So drill presses, lathes, milling machines need to be equipped with these chuck guards. So here you have that protective shield around the lathe. It's oftentimes not feasible to completely enclose the lathe, but you do need to have a protective shield like this one. All right, so these are just some photos of different pieces of equipment. And if we were, in person, I would ask you whether this is guarded properly. But we'll just start with the one on the left. So we have a rotating auger. Is that guarded properly? Brad says no, right? Yeah, so you can look at those rotating parts. You can totally, get a hand or an arm caught in there. So that would need to be guarded probably with a fixed barrier guard. And then on the right, it looks like we have a shear. Would you say that this is properly guarded? What do y'all think? I would say it's hard to tell, right? So this is an example of when, yeah, maybe. So this is an example of when we would probably use the gotcha stick and see whether that opening at the bottom is sufficient. It looks like he can still fit his hands underneath that guard, but it just depends on where that shear point is located and how far away it is. With shears, you also want to check behind the equipment as well to make sure that you can't access that shear point from behind. All right, what about the drill press on the left here? Yes, Brad says yes. It's correct. Yep, so you've got that chuck guard there. That looks great. What about the lathe on the right? I'm going to say no. All right, so they need a protective shield there. Yep. All right, good. All right, what about this equipment? Think about, what we talked about at the beginning, where you shouldn't be able to access the hazards by reaching under, over, through, or around the guards. It looks like, right, you could probably reach over this guard. So this guarding would not be sufficient. And then if you come around to the other side, you can see that it's completely exposed. So this is not a good example of proper machine guarding. You would need to add a lot of guarding here. Yeah, Steven says it's not sufficient. That's correct. Okay, so I'm going to just briefly cover one of the machine guarding standards. OSHA has several different standards that address machine guarding. 1910-212 includes the general machine guarding requirements, whereas the rest of the machine guarding standards address specific types of machinery. So, for example, 215 covers your grinders or abrasive wheels. 217 is mechanical power presses. All right, so 1910-212A1 includes that overarching general requirement that employees must be protected from machine hazards, such as those created by the point of operation, in-running nip points, rotating parts, flying chips and sparks. So if a particular machine hazard cannot be cited under one of the machine-specific standards or under the point of operation standard, then it's going to be cited here. This is kind of considered like the general duty clause for machine guarding. And then 1910-212A3II gets a little more specific. So this is where, point of operation hazards are cited. And quite simply, the standard states that the point of operation on machines must be guarded. Let's see here. All right, so here's an example or a photo of a press brake. Again, these are used to bend metal, and you can see here that the point of operation is not guarded. This press brake was actually involved in an amputation. So there are on the foot pedal, and the primary operator thought that the other operator was all set, so he stepped on the pedal and started the machine. However, was still feeding the stock into the press, and so several of his fingers were amputated. Fan blades. So if you have a fan that is located 7 feet above the floor, or less than 7 feet above the floor or working level, then it needs to be equipped with a guard, and the openings in the guard cannot be greater than 1/2 inch. And then what about hand tools? So are hand tools considered a sufficient means of guarding? They're not, right? So hand tools cannot be used as a substitute for guarding. They can be used, but you do need to make sure that your proper machine guarding is also in place. And then lastly, machines do need to be anchored to prevent, walking. We call it walking or moving when they're in operation. We oftentimes see like drill presses and pedestal grinders and belt sanders also not being anchored. But once a permanent location for a piece of machinery has been identified, it does need to be anchored to the ground. All right, so that is it for my section. So I am going to hand it on over to Paige. Paige is our safety branch manager with our OSHA consultation program. She's also an instructor and a course director with our OSHA Training Institute. And she also manages our environmental program. So Paige, all yours.
All right, thank you, Rachel. Yeah, as Rachel mentioned, one of the main things I do is teaching, but also the safety and health consultation program. And so just to give you a little bit of information on that, every state's required to have, or every state has this program. So in Georgia, it's located at Georgia Tech. And I think Kenny Davis will probably maybe already has put our website into the chat. But we're a free service for small businesses in Georgia. And we just try to help companies get into compliance with OSHA regulations, whether you want noise sampling or air sampling, or you want us to come out and look at your machine guarding, or if you want us to do a full walkthrough. We review safety and health management, electrical, air, noise, machine guarding, lockout, tagout, whatever you need. So we do, if it's something you're interested in, right now we have a very low backlog, so we're able to respond pretty fast. And Paul, it looks like, put the website in our chat. So if you're interested in our services, you can go to our website and see a little bit more about what we do and contact us and request our services. So with that, though, I will carry on. I'm just going to touch briefly on a couple things, and then we can get to the question and answers part. So 215s, your abrasive wheel machinery. A majority of companies that have machinery are going to have this. The main things you want to do is make sure that this work rest is within 1/8 of an inch. First of all, you want to make sure it has a work rest. Make sure it's within 1/8 of an inch of the wheel. Make sure you have your guard here. And just know that every time you use your wheel, that tool rest is a little bit further apart, because that wheel wears down every single time you're using it. So you want to keep adjusting it so that it's at the right distance. Tongue guard can't exceed 1/4 of an inch from the wheel. And note how that tongue guard is put on there. Occasionally I go to companies and they have it in the parallel position rather than the perpendicular position. And so you just want to make sure that it is put on there properly and adjusted to within 1/4 of an inch of the wheel. And you will have to make sure that the wheel itself is inspected prior to mounting, because if there's something wrong with it, if it's a damaged wheel, then it could break and you would have flying parts that could cause a serious injury or even a fatality. So immediately before mounting, you want to make sure that the wheels are closely inspected through a ring test. And this gives you a little bit of information on that. So you would hold the wheel in a vertical position, strike the wheel with a non-metal object, and then if the wheel creates the ringing effect, it should be in good condition. But if there's a crack or something, it'll have a dead space and it'll be more of a thud, and you won't hear that ring. Regardless, when you put the wheel on, make sure you're not standing in front of it when you start it for the first time, because even if you do that ring test, something could still be wrong. And so you want to make sure that you take all precautions prior to starting up the equipment. And here's just an example of what can happen. a wheel exploded and went across the shop area and damaged the window. Luckily, I'm not sure if anyone was hurt in that or not, but hopefully not. And so we have a tech guide. If any of you want access to this, let us know and we can send this to you. We have a lot of companies that use these and put them up by the grinder as a reminder to people as to what those measurements are and what the safety requirements are for the bench grinder. They also have those little tools that you can buy that have the 1/4 inch and the 1/8 inch so that you don't have to constantly get out your tape measure to make sure it's adjusted properly. They can just use that little tool and put it in there and make sure that it's adjusted properly. And then 1910-219 mechanical power transmission apparatus. Rachel talked really briefly about this at the beginning, how a lot of these are going to have your fixed guard in place. So if you have shafts, any kind of rotating shafts, they have to be guarded if they're 7 feet or less above the floor or platform. But what you really want to remember, although there is the 7-foot rule for machine guarding in general, if it's accessible, it still has to be guarded. So even if it's 7 feet from a platform, but you have people working up there that can still access it, maybe they're really tall and they can reach their hand right up there and access it, then still make sure it's guarded. So the 7-foot rule is not a bad rule, but please make sure that if it's accessible, it does get guarded. So you got to make sure that your shafting, all your rotating shafts are guarded. And your shafts that stick out, so your projecting shaft ends, if you guys can see these two sticking out here, they cannot stick out more than half the diameter of the shaft. So you would either cut it off so that it doesn't stick out more than half the diameter, or you would put a cover on it like the bottom picture. So you have to make sure that those are guarded as well. And obviously in this top picture in particular, there's a lot of guarding issues that you would want to take into account. That top guard right there doesn't seem to do much of anything. Here's just rotating shafts and couplings. Make sure they're guarded. They can pull a person's arm, shirt, sleeve, finger, hair into it. So make sure that it's properly guarded. And here's a picture, and this is an actual picture of someone's hair that got wrapped around a rotating shaft. There's another picture we have that we don't show because it's just kind of, it bothers people. That makes their stomach turn a little bit, but it actually shows the person with half of their head, the scalp, the hair taken off of their head. So this can happen. It has happened. It does happen. So make sure that your rotating shafts, even if they're smooth, they need to be guarded. Any pulleys, your belt and pulley right here, that needs to be guarded. If you can see there in the middle, it looks like you also have a projecting shaft end that's sticking out. So you want to make sure that those are guarded, and broken or cracked pulleys should be taken out of service or not used. And this picture, I use this picture all the time. I see this picture all the time. And every time my stomach turns with that guy's head right there by that belt and pulley, obviously. And this could be one of those things where it's down in a room where people don't go very often, or maybe it's up high, but at some point people do go there because there's accessibility right now. That guy, his head is right by that belt and pulley, so it has to be guarded. Belt, rope, and chain drives, again, they have to make sure that you're guarded. You can see a picture here where we got lots of belts and pulleys and rotating parts that all need to be guarded. Meshing gears have to be guarded. I have a picture coming up right here. So anything like that, you can see they put the top guard on, but you can still reach around. Remember Rachel said in the beginning, reach around, over, under, through, or otherwise access the hazard. And you can totally access the hazard right here. So you have to install additional guarding on that to guard those gears. Gears would always have to be guarded. And your chain and sprockets is very common. We see this all the time. So you want to make sure that these are guarded as well. And keep in mind, when you've got chains and sprockets and belts and pulleys, look at the back side of them too. So you want to make sure that they're guarded, but you also need to see, can I reach over that guard and access it from the back? Because we see that happening a lot as well. So make sure that it's fully guarded so that you can't access the hazard. Portable hand tools. One of the main things I'm going to tell you about hand tools is just follow manufacturer's instructions, keep them in good condition. If there's something wrong with them, make sure that they're taken out of service. And when I say taken out of service, don't just throw them in the corner because someone will use them again, right? So make sure that you have a good out of service so that they don't just pick it up and use it. And it is the employer's responsibility to make sure they're in safe, good working condition, even if it's personal tools that the employees brought on themselves. And your compressed air should, compressed air should not be used for cleaning unless it's regulated down to 30 PSI or less and have effective chip guarding and PPE. Compressed air, when you're using your air guns and air nozzles, that's usually used for cleaning. And so in those situations, make sure that it is regulated down to 30 PSI or less when dead ended. A lot of times you'll see the nozzles that have the little slits in the side. So then if it goes against your hand or your body part, the air will go out the side and you won't have more than 30 PSI going through that end. And it's really important you train employees on that. It can cause embolisms and other serious injuries. So make sure that and make sure employees aren't cleaning themselves off, blowing themselves off with those compressed air guns. Make sure all your electrical power tools are fitted with safety guards and switches. And like I said, with all hand tools, power and not, make sure you're following manufacturer's recommendations with how to use it, how to maintain it, what kind of inspections need to be done, when should it be taken out of service. And so this would be a hammer, and we would see something like this a lot. What happens a lot of times with something like this, they put tape on it, right? You put tape on it, it's all good because duct tape fixes everything. So we would not want to do that. You need to make sure that you train the employees to identify those hazards and take it out of service. Let them know that you will buy them another hammer. They don't have to keep using this one because the head will fly across at some point in time and hit somebody. So, and this is very, very common. On the left-hand side, we see these radiator style clamps that are used for compressed air. Those are not designed for compressed air. So you want to make sure that you're using the right kind of clamps. The one on the right is most preferable, but there are other types that you can use. You just have to make sure that whatever it is, the manufacturer has rated it for compressed air use and at the rate that you're using it. And here are just some resources that you can have. If you have any questions for us, you can go to that website and get all of our contact information, and we can send you any of this information that you want. So we have hardwood training materials. There's on OSHA's website, if you go to their e-tool, they have loads of information on machine guarding. So it's just ETOOL, OSHA's e-tool, and you can find all kinds of e-tools, not just on machine guarding. You can find it on several things, and there's a lot of great resources there. Same thing, a lot of stuff from OSHA. So if you just go on there, we just want to let you know they do have a lot of information on their website. All right, that is it for me. Aisha or Donna, do one of you want to step in now, or Lauren? For the question.
Yeah, I will step in for questions at this time. So let's see if anybody has any questions. Like I said, that you can enter it in the Q&A box. We do have a couple of questions. One is from Stephen McLaughlin. It says, what about machines that are of age and are difficult to design / implement guarding? Can we still be cited for old machines not having proper guards?
Yes, you can. So yeah, unfortunately there's not, or fortunately, I don't know, depending on which way you're looking at it, there's not a grandfather clause for old equipment. So we do realize that there is some old equipment out there and it works better than newer equipment a lot of times. So you want to keep it, but it doesn't have the proper guarding in place. And what OSHA would expect you to do is to retrofit that with the proper type of guarding for the machine. Sometimes you can reach out to the manufacturer and they have a retrofit for it. And then other times you're kind of on your own a little bit to try and figure out how can you guard it.
All right, and oh, go ahead.
Lauren, I have a couple of people who have their hands raised. Stephen McLaughlin, I'll unmute him. Stephen, I'm unmuting you.
Hey, I'm not sure. I might have not meant to raise my hand on this.
Okay, no worries. Teresa Williams. Teresa.
Oh, I'm sorry. I was just answering to the earlier guarding. I don't have a question. Thank you.
What about Mitchell?
Yeah, Mitchell submitted a question. I can read it if you like, or Mitchell, you can speak and ask the question.
Well, I mean, I'm happy to ask.
Okay.
I see tripwires on a machine. in my opinion, they only limit the extent of the injury. So I was just curious as why they were included as a machine guard.
That's a good question. Yeah, we we don't like to see tripwires being used as the only means of guarding. Sometimes that is the case depending on the type of work that's being done, but most of the time it's going to be a secondary means of guarding. So maybe you have a conveyor belt and you have your in running net points guarded, but then you also have a tripwire maybe around the perimeter. But with some like rollers, sometimes you can't have like a barrier guard or a point of operation guard, so you would need to use a tripwire. It's not favorable for just the primary means of guarding.
The other thing I'd like to mention with that too is a lot of times when we see something like that, if you have mills or calendars, which a lot of companies we go to don't have those, but if you're maybe a rubber plant or certain types, they have mills and calendars. And if you get into that standard, unfortunately, that's kind of how you guard it. Not necessarily tripwires as much as they're called, well, I guess they're called body trips or belly bars, and they have different names for them. So I think usually for me, about the only time that I find that acceptable is when we're looking at maybe mills and calendars. But Rachel's absolutely right. That alone usually isn't going to be sufficient.
Hey, Paige, can I jump in here?
Yep.
Hey, everybody. This is Paul Schlumper. I work with Paige and Rachel and Kenny. The other thing I like to remind folks whenever we get into a good discussion like this, and Mitchell, I think your point is an excellent point, is that, guarding, all machines are not created equal when it comes to guarding. I mean, expectations of guarding a point of operation on a mechanical power press are different than expectations of guarding, say, a bandsaw. So you certainly do the best you can in terms of providing an ideal guard that protects you over, under, around, or through from getting into the hazard. But when you have situations like what Rachel showed with those rollers and the limit switches, you want to keep in mind the hierarchy of controls. And obviously we want to engineer out the hazard in every possible way if we can. If our guard that we've got in place does not do that, then we may need to supplement something like a tripwire or a saw guard with administrative controls and possibly PPE.
Okay, so I wanted to jump in. I saw that Sonny Zimblowski has a question. Aisha, would you be able to take her off mute?
Who was it?
Sonny Zimblowski.
Okay. There you go.
Hello.
Sonny, are you there?
Yes, can you hear me?
Yes, we can hear you.
Okay. Well, I wrote down I sent the question. So essentially, I think y'all are kind of touching on it, but how to when you're applying guards to a tool, how do you balance if the potential guards may pose an additional hazard, such as creating pinch points for materials, like on the exit? Like, I guess I was just with shears and the back of shears being guarded. Like, if material normally falls, and I'm confused how you would guard against that, which wouldn't cause another hazard for the material interaction.
Yeah, you bring up a very good point. It's one of the things that we talk about a lot when we're teaching this, and I might have Paul jump in a little bit on this. But you're absolutely right. One of the things that we always talk about is when you install a guard, you have to make sure that it doesn't create a new hazard. And shear is exactly a lot of times the type of hazard that's introduced, a new shear point. And so that's why it's really important to work with maintenance and others to make sure that they realize that, yeah, we got to get a guard in place, but we have to make sure the new guard it works well It doesn't create a new hazard. The employees are actually going to keep it in place, because the other problem that happens sometimes is the guard itself creates a barrier, or makes it more difficult to do the job that they want to do. And as soon as you do that, people are going to start taking guards off. So I always say you want to set the employees up to succeed in safety and health, not fail at it. So you want to do a change analysis, look at the guards, get as many people involved as you need to make sure that that doesn't happen. And what I find on shears sometimes is they end up guarding by distance. They'll put a table or a tote or something in place to provide distance rather than having an actual physical guard back there. Paul, do you want to go ahead and jump in from there?
Actually, Paige, I think you said everything I was going to say. You did a really good job. I mean, I think I would approach machine guarding like any other project. You know, get a lot of different perspectives involved on the team. Certainly get operators and supervisors, as well as engineers and safety and health professionals. But get different perspectives, and you know, make sure you've tried to identify the potential downfalls of the guard before you go ahead and install it. So yeah, hopefully, when you put the guard on, you've addressed any potential additional hazards that might be present.
Well, I guess the question I have is, so I guess like with the shear, like distance was the alternative for the guard as the guarding mechanism. So instead of a physical guard, distance would be appropriate because it would cause those other hazards. So I guess you assess it and then try to come up with a alternative kind of guard if able.
Yeah. So, yeah, and that's and honestly, we try to help companies with that sometimes. Occasionally, that's actually one of the main reasons companies have us out. They'll have a piece of equipment that they really are just struggling on how to guard it, and so we don't always have an answer, but we certainly can come out there and provide different perspective and look at it. And yeah, as far as shears, yeah, a lot of times I do see distance. They put something behind there to keep, as long as you can keep the employees and people back far enough to where they can't access that point of operation, because you're not usually going to have a complete physical barrier guard in the back of the shear. A lot of times it's just not going to be, it's not going to work. Paul, were you going to add something? I saw you unmuted yourself.
No, I think the only other thing is when you look at location or distance, that is one of the easier options to defeat. So I'm always a little bit concerned about, you know, kind of playing what if and what can go wrong. And the problem with location or distance, one of the problems is that it only protects the person or persons who are holding the piece, right? So other people that walk up to the workstation, you need to take them into account too, in terms of maybe side guards or something, just to keep people away from the point of operation that aren't directly involved in holding the piece.
Yeah, absolutely. When I think of a location or distance on a shear, I'm only thinking about the backside. You still have to deal with the front and the sides. But that brings up a good point too, Paul. On presses and sometimes people forget about the sides, and you can, you know, it might be guarded from the front. Rachel showed that one picture of a yellow guard in the front, but sometimes on the sides, you can just stick your hands right in there. Anyone can walk right up to them.
Brad, is your hand raised again? Did you have another question?
Raised for the first time.
Okay.
So good to see you again, Paige, Dana, Paul. It's been a week since I saw you guys. Question for you guys. I worked for retail logistics, Macy's, and we have a room where we do a lot of furniture repair that come in. We have belt sanders, we have table saws, drill presses that were built probably when the building was built in the 60s. The guards are sometimes hit or miss here, which is a constant battle. So you hit the right target there when they take them off, and it's easy, it's in the way, etc. But are we able to engineer something versus having to go buy a drill press guard? Can we engineer something? We have a guy here who can fabricate things. The tool rest, the tongue guard, the belt sander in particular has a guard on it, but it's like I said, old, and there is a gap there. Are we able to do something ourselves and that be OSHA compliant, or do we have to do a commercial for the, you know, drill press or the sander itself?
I guess I could start out with this one. I would say yes, as long as you're still meeting the OSHA requirements and you're meeting that requirement that you can't access the hazards by reaching under, over, through, or around the guards.
Okay.
We work with plenty of companies that they do fabricate their own guards. We work with a lot of metal fab shops, and so I'll say, hey, like this needs more guarding, and they're like, no problem, you know, we can make that. So I would say that's fine, especially for your barrier guards.
Yeah.
But you want to make sure that you're still enclosing all of the hazardous parts, you know, any in-running nip points are not accessible, things like that.
Gotcha. Yeah, my eyes have been opened once attending these classes here. I'm going, yeah, I see that, and it's a lot of new stuff here. So
yeah,
they're mad at me right now. They're like, you didn't know this stuff a month ago. I'm like, I didn't, but I do now. So
We get that a lot, Brad.
I know, Paul, exactly. So
can I add something to what Rachel said? I thought that was a good answer, Rachel. That, you know, in the case that you're talking about, Brad, you might want to at least do some research and look into what the manufacturer's guards look like, how they perform,
Yes, sir.
as well as industry, you know, best practice, right?
Okay.
I certainly 100% agree with what Rachel said. You can make your own guard. And I think ultimately what OSHA would want is that the guard meets performance expectations. It's going to perform at a level that would at least be as good as the manufacturer or industry standard.
Gotcha. I would prefer if we could just go buy new stuff and have all the latest and greatest, but you know, it's, you know, retail is hard right now. So I'm going to look into this, and I appreciate your guys' answers, and great seeing you all again.
I do have a question, another question from Stephen McLaughlin. It says sometimes when you're talking about sanders, sometimes the sander has to have an open face or belt. What does OSHA say about belt sanders?
Paul, I was waiting for you to take it.
Well, I'll start out by saying
I'm
that-
sorry. I was trying to leave an opening for you, Paige. I'll jump in. I didn't want to
I'll let y'all go.
hog all the time here. So definitely check the OSHA standard on that. I mean, in running nip points have to be guarded regardless. So you do have to guard those. There's really not much decision to make, but OSHA does allow you to have basically
All right, Rachel, it's your turn.
Yeah, I think it's up to you, Rachel.
Well, yeah, I was going to say that the in-running nip point, the belt itself can be exposed, but as long as that in-running nip point is guarded. I know there is a specific standard or a specific requirement in the portable power tools standard, but I'm pretty sure what it says is that in-running nip point needs to be guarded, and then the back run of the belt needs to be guarded. So the front run can be left unguarded so that you can perform the work. Oh, and Dana just put in the chat a belt sander enforcement truck. I didn't even know they had one of those. So thanks, Dana.
Totally misspelled, but it's in there. Totally.
That's what I'm saying. Oh, man, I just literally asked the question, how do you make a guard for a tool that's designed to be used without a guard? Like a belt sander's you can't use a guard.
Well, one thing I was going to say is that for belt sanders, what the standard will say is that the in-running nip points have to be guarded. And one of the things that I've had companies have to do is they actually have had to purchase a different type of sander that actually was designed for the job that they were doing. So there are different types of sanders out there for different types of sanding that you're doing. So you're right. There are some small sanders that you can't sand, you can't do the job that you want to do on it without removing the guard. So what you have to do a lot of times, you have to go purchase one that is designed for that, that's large enough or small enough for the job that you're trying to do.
All right, so does anybody else have any other questions at this time? Because if I will, how about this? If anyone else has any other questions, you can put them in the Q&A box. But since we are kind of running towards the end of the presentation, I do want to go over some upcoming events that we have. So we are going to be continuing our CARES Act training and development series. We have a webinar next Wednesday, February 24th on leading employee engagement using human and business strategies. Our speaker for that event is Teresa Cummings. We've had 2 previous webinars with her, and both of them have been excellent. She's a very engaging speaker. And so I expect that this 3rd webinar will be just as great as the previous 2. We also do have more events coming up with our Georgia Tech Safety, Health, and Environmental Services team. Next Tuesday, February 23rd, we are having a health hazard awareness webinar. It's going to be at the same time, 1:00 p.m. to around 2:15, 2:30. It's free to attend for everybody, but you must register. We are also going to be having on Tuesday, March 2nd, a walking working surfaces standard webinar on walking working surfaces. And again, it's free to attend, but everybody who wants to attend must register in advance. And then finally, as part of our CARES Act series with Georgia Tech Seas, we are having a series of roundtables. Our first roundtable was last Friday. It was a safety and health management systems roundtable. We had a good turnout and discussion. This Friday, February 19th at 10 a.m., we're going to be having a heat stress roundtable, which is free to attend. And then on Friday, March 5th, we will be having a hazardous materials safety roundtable. I will make sure that the links to register are available in the chat. There's also a link on the slide for all upcoming events that you can visit. And with that, I wanted to say thank you all for joining us. If you want to learn more about our MBDA centers or our center network, you can go to our website. And the only other question I had was from Chris Fox wanting to know if a copy of the PowerPoint will be available. The answer is yes, we can make that available, and also a recording, as a reminder, a recording of this presentation will be sent out to those who registered. So I guess at this time, if we don't have any more questions, I wanted to say thank you to everybody for attending. And we definitely hope to see you at more of our events coming up within the next couple weeks.